Hello and welcome. I am Firestorm, and welcome to Firestorm's Guide to the Universe. This is the first time I've done something like this, so if you guys are interested or enjoy this type of content, be sure to let me know and I might make more. Today, we will be exploring the life cycles, births, and deaths of stars. Let's start off with the basics. What is a star? A star is a celestial object made mostly of hydrogen and helium that produces light and heat through a reaction known as nuclear fusion. Stars are very large. Even the smallest of stars are larger than Jupiter, our most massive planet. Stars can emit so much energy that we can see them from up to thousands of light years away with the naked eye. That means if we traveled at the speed of light, it would take us thousands of years to get there. That must be really bright. So the question remains in our minds: how do stars even form? Well, there are specific places where stars start to form. We know these as nebulas. Nebulas are huge, cold clouds of gases that are mostly made of hydrogen and helium. Inside nebulas, the gases start to become warmer and more dense due to gravity pulling it all together. Eventually, the heat and spin of this ball of atoms stops gravity from pushing it together even further. Eventually, this ball heats up so much that it starts nuclear fusion. Thus, a star is born. The lives of different masses of stars are very similar, up until they die. Let's walk through the life of low mass and high mass stars. The majority of a star's life is spent using their fuel through nuclear fusion. Nuclear fusion happens when two atomic nuclei come together to form one atomic nuclei and subatomic particles like protons and neutrons. This reaction takes place in a star's core. A star starts out by burning hydrogen into helium. Small stars can continue burning hydrogen for tens of billions of years, while very large stars will burn through their hydrogen after tens of millions of years. When a low-mass star runs out of hydrogen, the helium that is left due to nuclear fusion contracts in the core. This causes the star to heat up and expand its outer layers, becoming a red giant. Eventually, the star sheds these outer layers and becomes a tiny, dense celestial body known as a white dwarf. A white dwarf slowly burns away what energy it has left, and scientists think once a white dwarf burns through all of its materials, it will turn into a black dwarf that emits no heat or light. Now, high-mass stars go out a little bit differently. There are two paths a dying high-mass star can take. When a high-mass star runs out of hydrogen, they will also contract at their core and expand their outer layers. However, the core gets so dense that it causes a supermassive explosion. We call these types of explosions supernovas. Supernovas can leave behind two different objects: a neutron star or a black hole. A neutron star is an extremely small yet dense celestial body. What is fascinating is how small and how dense these stars can be. A neutron star is about the size of a large city and can hold many times the mass of our sun. A spoonful of a neutron star likely weighs as much as the Earth, if not more. These form from every proton and electron in a star being crushed together into neutrons. These newly formed neutrons are able to stop the star from collapsing even further. But what happens if the star was even bigger and a neutron star didn't form? Only the largest stars are lucky enough to explode and form black holes. Black holes are places in space where gravity has become so strong that light cannot escape. Since light gets sucked into a black hole, the actual black hole is invisible. We know they exist due to their pull on other stars as well as the light they eat that surrounds it. Kind of creepy to think about. Most black holes that are formed by stars are very small, only a dozen to a few dozen miles across. However, there are black holes that are supermassive, and they are very large. There is one at the center of our galaxy that is more than 14 million miles in diameter and 4 million solar masses. To understand that better, the diameter of this black hole is about 16 suns across and holds 4 million times more stuff inside it than our sun alone. That is a lot of mass. We don't really understand how these black holes became so large, but these black holes hold together galaxies. Now, remember when we talked about supernovas? When a really big star explodes? Supernovas propel gas out into different parts of space. This gas is what creates nebulas, the birthplace of new stars. So, our cycle continues all over again, thanks to the explosion of really big stars. Thank you if you watched all the way through. I appreciate it. This is my first time making one of these, so if you enjoyed it, let me know. Thank you guys.